So this is part one of undetermined coefficients. So undetermined coefficients is the first technique that we're going to learn how to solve a higher order differential equation that's non-homogeneous. So I just want us to remember the solution to a non-homogeneous is y equals yc plus yp, where yc is the solution to the corresponding homogeneous equation, which means it's equal to 0, not g of x. And then yp is a particular solution to the non-homogeneous. So the process for undetermined coefficients is basically to look at our g of x and guess. It's going to be an educated guess, though. And it's going to be of similar form of your g of x. And then we're going to solve by equating coefficients. So the pros of this technique is that it's not too hard, a little bit of algebra, and it basically, like I just said, reduces to algebra. The cons of this method is it only works for some functions. But they are common ones. So the general method of solving non-homogeneous is find yc, find yp, and add them together. So let's write that out. So we will guess yp, and it is a reasonable guess. It's going to be the same form as your g of x function that makes this a non-homogeneous. And then we will check it, plug it in and equate coefficients. And then our third step is put it together, our general solution. Is y equals yc plus yp. So again, whatever order it is, we get our constant of coefficients from our yc. So our first example. Okay, so here's a non-homogeneous. It's not homogeneous since we have a function right here on the right. So that's my g of x. So the first thing we do, looking at our general method, is we find yc, which means we ignore g of x. So we take the left side and set it equal to 0 instead of our g of x, and we solve for it. Since this is constant coefficients, we can use the previous method of solving for constant coefficients. So we're going to let y equals e to the rx. And let's plug these into our differential equation. We're given differential equation. So this goes there, this goes there, and y goes in place of y. So 12 times y is e to the rx. Factor it out. We know that cannot equal to 0. So r squared minus 4r minus 12 is equal to 0. Let's see if that factors. Okay, so it looks like it does factor. That's equal to negative 4 in the middle. So for YC, we have e to the 6x and e to the minus 2x. So we can see here our general solution for YC is y equals C1 e to the 6x plus C2 e to the minus 2x, coming from our fundamental set right here. The r's created the fundamental set because they were distinct, and so on. So we found our YC, and now we're going to guess our YP. A reasonable guess, it's got to be in the same form of g of x. And then we're going to check to find the coefficients. We're going to equate the coefficients is what it's called. So for YP, we're going to guess the same form. So YP as g of x. Our g of x is equal to 3e 5x. 3e to the 5x. So our guess, our YP, is going to be, well, we're not guessing particular values. Well, we are. We're going to find it. It's a e to the 5x. So in order to plug it in and equate coefficients, we got to find the first derivative and second derivative. And our second derivative. And let's plug it into our equation. So our y second derivative is 25. So let's simplify the left side, and then we can equate coefficients. So adding these numbers up, 25 minus 20 is 5 minus 12. That adds to minus 7. They're all the same term. So looking at both sides, we have e to the 5x on the left, e to the 5x on the right. So therefore, this must equal to 3. So write that out, minus 7a equals to 3. Solve for a, because then we have our answer for our solution. So now we have our YP. Our YP is minus 3/7 instead of a, e to the 5x. So now our step 3, our general solution. We put them together, we add YC plus YP, and that's our general solution. See, I should have circled it back here. So that's my YC. 6 and negative 2. Then you add your particular. Okay, so here's our next example. So we always start off with finding YC. So to find YC, we set the left side equal to 0. So usually, I don't usually write out YC. I usually just write this out, and then at the end, I'll add YC in the final solution. So YP, our guess. What is our G of X? So here's a situation about if we were just to let our YP equal to sine of 3t, when we took the derivative, we'd see cosine. And to be able to equate coefficients there, we will also have to add b cosine of 3t. So it doesn't matter the order. We could have done a cosine of 3t plus, obviously, we'll just get something different for a and b flip-flopped. So plugging all the pieces in, y prime first, y double prime. So let's clean up the left side before we equate coefficients. Distribute, distribute. Okay, now let's go ahead and add up all of our like terms. I'll start with sine. Cosine. So we have this many of the sines, and then 9b minus 12b, 6a minus 12b of the cosine of 3t's. So equating coefficients means that this coefficient in front of the sine of 3t has to equal to 5. And this coefficient in front of the sine has to equal to 0 since there's no cosine over there. So let's write that out. So this looks like we can use linear algebra to solve, or just two equations to a known. Use algebra if you feel like it. So I'll utilize Kramer's. So again, remember, we just replace the first row with b, and the second row stays the same and find the determinant. Now we replace the second row with b for a2, and the determinant. So that's 0. So a, oops, I guess a and b, I gotta be careful there. This a here, a1, our b is a2 divided by the divided by the determinant of a. So my solution for yp and we found a and b. So yp is equal to minus 1/3. So that's our yp. Remember our general solution though? That's our particular solution. Our general solution is yc plus yp, so you get your constants from the yc. Y equals, where's my yc? Here's my yc, except of course we don't write yc. Oops, it's yc plus my particular. So yc is your yc is your solution to your homogeneous, and your particular we just found, we add it to that because it's minus. And that's our general solution for that example. And our last example, so I picked the same left side of the equation. So we have the solution to YC. Our YC is equal to C1 e to the minus 3x plus C2 e to the x. So YP, our guess. Now this is a quadratic. Even though it's missing the middle term, you need to guess all the terms. You can't just say ax squared and plus b. So remember, because when you take the derivative of 3x squared or ax squared, you'll get an x term, which needs to be included in our guess so that we can equate the coefficients. Otherwise, you'll get a contradiction if you guess the wrong thing. So we take the derivative, take the second derivative, and let's plug it in. So let's simplify the left side using algebra. Told you it'd be a lot of algebra. And let's rearrange it. Write 3x squared first. Okay, so equating coefficients. This has to equal to that. This has to equal to 0. And this has to equal to 4. Writing them out, here we can solve for a, it's minus 1. If a is negative 1, we can back substitute. It's minus 4. So that's minus 4/3. Made a mistake right there. It is a minus 3c. So this is a minus 3c. So when this is a minus, the minus, it's minus 26/9. So our solution is, remember it's y equals yc plus yp. We've had our yc from the previous example. Plus my yp. I didn't write out my yp, I could though. So remember our yp in general was ax squared plus bx plus c. So our yp is minus x squared minus 4/3 x minus 26/9. So I just add that. And that is my general solution.